A very Merry Christmas. Here's Baji. We're gonna drink some coffee, eat some snacks, and some fruit together. And here's Baji. La 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 la. Here's some coffee. Here's a book. Merry Christmas! Please do join us and say hi in the chat. A very Merry Christmas. How are you guys? A very Merry Christmas. A very Merry Christmas. A very Merry Christmas. A very Merry Christmas. La 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 la. I'm gonna wash the strawberries and then I'll sit down with you guys. Fuji, no Fuji. Fuji, no. I'm washing the strawberries. I'll be right with you. Sitting down soon here. I hope that many of you will be joining to say hi on Christmas Day. And we can do a little hangout. And we can chat. I can have my strawberries. Drink my coffee. And then we will finish the dark matter topic that we started. I've been humming Interstellar all day. Hello. Hello, my loves. Hello, my loves. I follow an organ talk person, as in she plays the organ. Oh my God, she's so good.
Can we please like, share, and subscribe? Can you like and subscribe? Happy birthday! Hello, Mike D. How are you doing? No hangover from last night. That's right. I'll pin a message. Victoria, hello. AWG, hello. Mike D, hello. Kashyap, hello. MD Akbar, hello. Wannabe Wayne, hello. Tumi bolle ami shunbo. How are you doing? Hello, Truth. Allison, Ricardo. Hello from Vermont. Hello to Vermont. Where's Baji Baba? Hello, Kashi. Bon appetit. Hello, Nusrat. Taj. Hello. Thank you guys for the likes and the hearts and the love and the chat messages. I know, I'm eating too many strawberries. Hello, Honeybee. Hello, Godzilla. Ryan Paul. Okay, before my coffee gets cold this time, I'm gonna drink it. $360, huh? Here's them. Here's my couch. Here's the other phone. Here's the TV. Here's some books. Here's the fridge. Pretty. Hello, Blessing. Hello, Arlindo. Hello, Khurshida. Lam Khurshida Lan. Hello, Sailor. I don't know what grabba is. Hello, Wayne. Oh, this coffee is so good. I needed a sip of that. Have you ever been to Mexico? Mexico? I have not. It's on my list. East Coast, yes. I'm on the East Coast of the US. Please do like, share, and subscribe, my guys and gals, my ladies and gents. We're gonna do a little physics lesson tonight as well, by the way. Hello, Kiwan. Thank you for subscribing, everybody. Please do like, share, and subscribe, my darlings. Merry Christmas. Merry, Merry Christmas. I'm from India, says Rishikesh. Or no, says Manas. Manas is saying, I'm from India, Rishikesh, Lakshman Jhula. You know, I do know. Hello, miss. I need a challenge for public place. Thank you for liking and subscribing, my darlings. Thank you so very much. Can we get 50 likes? Oh, 30 likes. Can we get 50 likes? How are you? Hello, Christian. Hello, Manas. Hello, Wow Challengers. Hello, Train P9M. Nice usernames, guys. Much appreciate all of you to join here. Thank you so very much for joining. Thank you so very much for joining. By the way, if I miss your message, type it again. Can be a little hard to scroll sometimes. That's why I have my other phone as well. But X list. What does that mean? Thank you for the gift, my darling. Hello, blessing. Your eyes are everything. Well, thank you so much. Christmas. Princey says hello. Merry King Jesus Day, says Francis. Hello. Hello to Godsey. Love you too. Manas is saying subscribe you. Thank you. Thank you for liking, sharing, and subscribing, my guys and gals. You are from sister. Hello, Mohammed. Bilal Khan. Thank you for the gifts. Oh my gosh. Let's see, who did the gift? Ricardo Ruiz is sending a flower. Thank you, Ricardo, for the flower. The flower. Let's see the top fans right now. Right here, right now. Number 1 is Train P9M. Thank you so much, Train, for your support and unconditional love. Really appreciate you. Number 2 is Manas Rawat. Hello, Manas. Number 3 is Godzilla. Hello, Godzilla. How's your day going? Number 4 is Blessing. Hello, Blessing. You are a blessing. Number 5 is Pandi Sakti. Pandi Sakti. I don't know how to say it, but hello. Number 6 is Kashyap Sushma. Number 7 is Tigodzi. Number 8 is Truth. The truth is spoken here, and that is that there is a lot of love and good wishes. Thank you for all of it. Number 9 is saying, number 9 is Muhammad Akbar Khan. Number 10 is Mahazali, something. Number 11 is Victoria. Number 12 is Sailor. Number 13 is Wanna Be Wayne. Number 14 is Cookies. I do have Cookies here as well with me. Number 15 is Clash Royale. Thank you, guys. Thank you for the hearts. Thank you for the floating hearts. Thank you for the love. Thank you for the chat messages. Thank you for the gifts. Really appreciate it. Japan is saying you a fine Middle Eastern. Thank you, Francis. There's a couple of mods here helping me out. A Middle Eastern. A Middle Eastern. A Middle East, a center east, a left east, a right east, a top east, a bottom east. Because the earth is round, we're all from the east. Possibly. We're all to the east of something. We're all to the east of something. Merry Christmas. Shalom, 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 shalom. Since I'm from the Middle East. Or no, wait. Salam alaikum. Since I'm from the Middle East. Shalom. Hello, Rick. Hello, CJ. Hello, Samson. Hello, Adam. Hello, Eddie. Hello, Armin. A criminal? Da-da-da-da. Da-da-da. 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 da 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 da. Shalom, salam, adab, namaskar, namaste, hello, welcome, swagat. What else do I know? Salam alaikum, wa alaikum salam. Everybody, you are welcome to this chat. Everyone, all, one and all. Zimbabwe, especially, you're welcome. Hello, Derek from Zimbabwe. Zimbabwe, Japan. Swagat hai means welcome in Hindi. What languages do you speak? English, Hindi, Bengali, Urdu. What's your name? What's your address? What's your color? What's your favorite color? What's your school? What's your office? You're a nut. Peanut? Walnut? Please be specific, guys. Which country are you from? Hello, Kamal. Kamal. Iran. At least I can say Iran properly. It's not Iran or Iraq. It's just Iran. Uruguay. Oh my gosh. Cannibal land. Palau. I need to go to Uruguay. In fact, I need to go to all of South America. It is my missing continent at this time. Hello, MH Panhavar. Hello, Kamal. Kamal. Smile if you like pizza. I hope we're all smiling. Belgium. Regards from Belgium. Indian, Sumit Funny. Musa. Linda. Steven. Oh no, Steven. Oh. Please don't give me any bad news. I'm sorry. It's Merry Christmas. And I just want to be happy. Hello, the UK. Thank you for smiling when you see my face. It does help. Soft like silk. Who? Hello from Bosnia. Goodness. Hello from Nigeria. Nigeria, Bosnia. Hey, Joel. Hello, good morning. Ajnabi mujhse la 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 la. I'm from Nepal. Hello, Nepal. How you know my brand from the UK? Excuse me. I don't know. What did I say? I've forgotten already. Thank you so much, everybody, for the chat messages, the likes, the shares, the subscribes, the hearts, the gifts. Everything is most appreciated. Nigeria. Ow! From Stiggutsy. Oh, you said hi from the UK. Hello, Spacey Locker. Are you from West Bengal? Hello, Kamal. Kya Kamal hai? Happy Christmas from New Zealand. Hello to New Zealand. Merry Christmas, my darlings. I love New Zealand people. They're so nice. Hello, Paul. Love your accent. Hello to Bangladesh. Hello, Puerto Rico. Hello, Republic of Dholakpur. Hello, Iran. Your country. South Africa. It's so beautiful there. So very beautiful there. Merry Christmas from Iowa. Hope you're having a wonderful day with family and friends. Hello, Jeremy. How is Iowa? Chole jabo, Khuda Hafiz. Khuda Hafiz. Assalamu alaikum, walaikum salam, and Khuda Hafiz. Indonesia, Jakarta. Man করিও না অনেক কথা বললাম. Okay. Are you Indian? Chota Bheem. Okay. Hello, Clash. Okay, I need to sorry, I need to microwave this coffee again. Sorry. Give me 1 second. I'll be right back. From here to here. Merch coming soon. That's very true. Please do subscribe. Please do like and subscribe. Thank you so very much. Hot coffee is the best. Thank you guys for 50 likes. Can we get 100 likes? Thank you so much. Good morning, my sweet sis. Good morning, brother. Jubair Tahe Tahsildar. Tahsildar, hello. Sumit Funny, hello. You know Hindi, please reply. आप हिंदी में कुछ कहो तब तो रिप्लाई करेंगे ना हिंदी में. आप बोलो क्या सुनना है आपको हिंदी में. Bittu Sharma is saying hi. Donald D is saying what? Something about slim. Nice smile, princess. Hello, Kenya. Hello, baby. You remind me of Queen Sheba. Who is that? Oh ho! Hello, Niall. Where are my peeps? Hello, Donald Duck. Hello, Denton. Hello, Texas. Hello, Samson. Hindi bhi aati hai. Of course, darling. Anything else? Baddie alert! Yes, it's coffee. 1 sec. Hi, Shuji. Suchi Mama! Did you poop on the floor? Oh, that is terrible, Sachi Mama. What have you done? Oh my goodness. Sachi has gone to the bathroom on the floor. Cup of tea, 2 sugars, please. Love, cheers. Hello, Humble. I'm intelligent, thank you. We will talk a little bit about dark matter in a bit. So hang tight, guys. This is a Swiss roll. This is from Aldi. I'll tell you where the Swiss roll is from. It's from Aldi. Also, I have peanut butter wafers. I already had this. तुम कहाँ से हो बताओ ना यार. I see something that I cannot read yet. Hello, Alexandra. Hello, baby Yoda. It's really good. Oh, yeah. You know, Aldi sent me this 2% reduced fat milk. And that's the only complaint I have because I wanted whole milk. Thank you for the likes, everybody. हाँ जी, सब्सक्राइब कीजिए, तब और पता चलेगा. Hello, Stanish. That can don't. The Bison. Hello, GKL. Hello, Joshua Johnson. You a cute Arab. A cute Arab. Hum is saying, B darling, I'm a card reader. Card said you'll soon be prego. Prego? Is that the waffle? Oh no, that's ego. Is that a waffle? I love the way you talk. Hello, baby Baba. Hello, Ellie. Hello, Honest. Hi, Swachi Mama. Sachi Mama is being very fidgety. Sachi, are you okay? What's wrong, baby? কি হয়েছে সোনা? Sachi Mama. I have to make sure everything is okay. She's sitting down. Sachi Mama. Do you need help? She's all the way up on the cabinet. Hello. Are you of Indian origin? She's talking to a spider. Where are you from? तुम्हारे shorts पे views बहुत कम है. Well, did you view my shorts and like and subscribe and share? Brain Lady. Hello, William. I think Suji is cleaning herself now. Okay. I have to keep an eye on my children while we speak. Kahan se ho? Hello, Subhakar. Thank you. I think her butt was itchy, but she's cleaning now. Sachi Mama, are you good now? Hi, Sachi. Let me show you. Hi, Sachi. There's Sachi. Hi, Sachi. Hi. Okay. How are you, Cosme? Cats are cool. What is the moment of inertia of disk? Tell me what to draw. Hello, Paula. Can you draw me? Or a cat? Study a little bit of the Veda and cosmology. Your thoughts, please. I cut the tops of strawberries and add gold cream. Hello, Harsh. Thank you guys so very much for being here and commenting and chatting. Hello, Kiwan. This is a coffee. This is a coffee. It's not vodka. It's been dry here in Boston. It's been very dry. Get something to eat and come back. We're gonna start the dark matter discussion as soon as I finish my coffee, okay? Give me like a couple more minutes. I'm gonna finish my coffee and then we're gonna finish the dark matter topic that we started a couple of days ago. Thank you for the likes and the shares and the subscribes. Thank you, thank you. I also have to keep an eye on the time. I am doing a dinner. Okay, I think I should be good. I should be good. Okay. How is everybody doing tonight? How's your Christmas going? It's in Egypt. We have landed in Egypt, in the pyramids. Hello, GPR. Hello, Howard. Douglas, Mike. Okay. I'm done with my Swiss roll. Coffee's almost done. We're going to be picking back up from this book. Dark matter is our frenemy. That's where we will start, okay? Everybody get your popcorn, get your warm drink, Christmas drink, eggnog, snacks, everything ready. Okay. We're gonna do some learning and discussing. My poor mod. Don't make their lives hard, guys. Stay in line, okay? Hello, baby booba. तुम्हारे स्कूल का नाम बताओ. What we will discuss tonight is pretty simple stuff. We will discuss the topic at a pretty high level. So Nothing too complicated. Boston Boston की है. Indeed. Okay, baby Yoda. I think so. It should be great. I don't add sugar. All right. Let's see. So remember, we have been talking about dark matter from this recent book that we picked up by Neil deGrasse Tyson. And this is called Astrophysics for People in a Hurry. It should be tagged on this live and whatnot. And we have been talking about this mysterious thing or phenomena called dark matter and how it interacts gravitationally but does not interact with light, does not seem to participate in nuclear fusion like ordinary matter does to make elements and the heavier elements, for example, above hydrogen and helium. Okay, but then it is found or definitely affects things gravitationally, especially in the halos of galaxies. It also seems to affect far away clusters of galaxies. So Zwicky, in his research and his measurements experimentally, found this effect of where in the faraway clusters of galaxies, like the Coma cluster, he saw that the galaxies were moving too fast, so much so that they really should have escaped the cluster within some millions of years, but that cluster is more like 10 billion years old. So it kind of brought about this need for the explanation of this more mass that was present in the cluster, which had nothing to do with at least the luminosity producing galaxies that we see there. So there is something there which seems to be contributing to more mass than we can see and pick up on electromagnetically and such. Because usually in astronomy, traditionally, and astronomy is one of the oldest sciences, people generally would see, look up in the night sky and see the objects that produce light. Typically, it was just visible light. And then we also opened our eyes in X-ray, gamma rays, radio waves, and such, as in we can also see light in other wavelengths depending on your instrument. But indeed, it seems like there are these clusters of galaxies where, from the speeds of those galaxies that are moving, it seems like there's more mass than we can really pick up on in hello Dave. Yes, we live stream about physics, cosmology, astronomy, and astrophysics. Okay, so thank you so much for joining. So it seems like we see this more mass implied by the movement, the speeds of these galaxies, but the mass is not producing any luminosity for us to pick up on. And generally, the things like stars, etc., we can pick up on their mass, and those are luminosity producing or light producing objects in the sky, or even a galaxy is a light producing object, but whatever light we're seeing is not matching up with the mass that we also see. So there's some other thing there that must be contributing to the mass, which only seems to she don't discuss UFO though. There seems to be this other mass which is affecting things gravitationally, but not electromagnetically. We also seem to, going back to, for example, the Big Bang nucleosynthesis. So this is something to do with the Coma cluster. And we have seen this with other clusters of galaxies as well. And it was first measured and discovered by Zwicky. Okay? This one scientist that we talked about. But then we actually, you could maybe, if this was to do with just one cluster, the Coma cluster, maybe we can say something like, oh, that Coma cluster is a peculiar cluster. Maybe something is really off about it, and this is the issue. But then we're actually seeing this effect in other clusters as well. And this was back in the 1900s. So this is quite soon after general theory of relativity, within like 20 years of that, okay? So pretty old. At this point, this topic that we discussed today, and we have been discussing for a few lives now, and in the past too, we have discussed this topic of dark matter is almost 100 years old. This mystery is almost 100 years old. From the 1930s, this has been bugging us. This has been confusing us. And we are picking up on evidence over time across these 100 years or so. And even now, this is a research topic. But I'm presenting kind of what we found when, right? In the 1930s, this Zwicky thing happened with the cluster business where people... where he picked up on this implied extra mass. And it was a very large quantity as well. Like it was a huge mass that was missing, that we couldn't see visibly in light. Then what happened was there was also Vera Rubin. And I believe that was more in the 1950s or 60s. Someone can correct me in the comments. Vera Rubin is another very important name in this business of dark matter. Okay, so many believe that she should have won the Nobel Prize for her contributions, and I don't believe that she did. But a lot of course, she did a lot of respectable, very, very important work, and also kind of anchored this topic as a more of a galaxy issue and not just about faraway clusters of galaxies, okay? So what Vera Rubin showed is that she did not win the Nobel Prize, correct? But she's a very important name, so please do look her up if you don't know about her. This is important work that she did, okay? So then after the Zwicky measurements, which showed about the cluster discrepancy, this is now Vera Rubin that is finding the same kind of situation of more mass that seems to exist but we cannot see in terms of observation with light. But it is now concerning galaxies. So even stars are orbiting the galactic centers of the galaxies that they're present in, and their orbital speeds were also too high. Some of these stars that are kind of out there, and we expect them to either have sort of a constant or slowing down kind of orbital speed, those also remained really high, the orbital speeds, that is. So now this is no longer about a cluster that is far, far away and the galaxies within that cluster behaving oddly, but about stars behaving oddly around their own galactic centers. And in fact, not just any galaxy, this is the case even with our very own home galaxy, the Milky Way. So now it is becoming a much more really intriguing and concerning problem, because gravitation is something we would like to say that we understand to a large extent, because gravitation, of course, has been around forever, since the days of Isaac Newton. And that was hundreds of years ago that he gave us equations, equations to quantify and explain this sort of action at a distance kind of situation, which is gravitation. It's an attractive force, brings matter together, matter clumping in the universe, etc., etc. Is happening because of this. And an explanation of it mathematically was given to us by Newton years ago. And then this gravitation situation was updated in the 1900s, within about 1915 or so, by Einstein with his general theory of relativity. So imagine now, if you're finding evidence which may point towards gravitation being something that we don't fully understand, because gravitation related motion is happening, which is not falling within our understanding of what we would expect. So those stars orbiting their galactic center, those galaxies orbiting their cluster center, all these speeds being too high, this is an issue. And it's not just a small issue. The estimates for the mass discrepancy, depending on where the issue is, was very high. And it was also a little bit not the same. Okay, so I think on average, there was this 6 times, a factor of 6 off of other matter. And then pretty much as we continue to find more and more evidence, at this point we think that there is most of the matter in the universe is dark matter. This matter that interacts gravitationally and not with light, and does not do nuclear fusion and all this other stuff, seems to be sort of a diffuse kind of matter, not very compact, not something that can become a planet or a comet, but it just kind of exists diffusely everywhere. And it seems to have also had a very important role in large-scale structure formation, as it seems to have helped out when we first formed our first galaxies in the universe, because that too is a question mark in the sense of understanding it more deeply. Now, we know that we, of course, formed galaxies in the universe at some point, because at some point there were no galaxies in the universe. It's like we have the before and after picture of the universe in that sense. The cosmic microwave background radiation, the photons we pick up on from those early universe times show us how things were then, when the universe was much younger. And of course, we see now how things are now. We have galaxies now. We didn't have galaxies then. So we have a distribution of matter in this universe that we kind of see. And we know it happened. But it would be nice to understand what are the intricacies that led to that exact distribution of matter, and why did matter clump in that way? What may have let gravitation win in certain spots in the universe, against anti-gravity or expansion of this universe, okay? Because we could have just kind of kept on expanding and never clumping and never having any overdensities of gravitation and whatnot. So we think that dark matter also has an important role there. Yes, please do like, share, subscribe, and come back anytime. Come back to our lives when we go live, and you can find these topics discussed in the past as well on my channel in the under the live tab of the channel. You can find and you can listen to these discussions as you go to bed or do something else, right? So these are what's going on. It sounds like, at least when Neil deGrasse was writing this book, the factor, the mass that was missing in terms of all that odd behavior of the galaxies and the stars, the same amount of mass was also needed in order to help the galaxies form. So you see how this doesn't sound much like a coincidence anymore. There is more and more, it's sort of this snowball of evidence that's forming to point towards something like this extra matter being present. And we call it dark matter because it does not interact with light. And we don't know exactly what it is. Okay. So now we will keep on reading from the book and finish up, because I kind of summarized for you here what we talked about earlier. And in this book, this is a simple popular science book, and it has these topics written already. And we will just kind of cover the rest of the chapter on dark matter and go from there. Hopefully, everybody's having a good time. How are you guys? Thank you. Thank you. Appreciate it, baby Yoda. All right. So dark matter is our frenemy. It's a friend and an enemy. Enemy in the sense we don't understand it, leads to this odd behavior of things. But friend in the sense that, well, it might have helped us form galaxies, because if that didn't happen, then there wouldn't be any galaxies, stars, planets, people, anything, right? So we have no clue what it is. It's kind of annoying, but we desperately need it in our calculations to arrive at an accurate description of the universe. So see how it's kind of a frenemy? It is not something that we can ignore. It's one of those things that you cannot ignore. You cannot, you may love, you may hate, but you cannot ignore, right? So scientists are generally uncomfortable whenever we must base our calculations on concepts we don't understand. But we'll do it if we have to. It's kind of like when you have no choice, then you have to do the thing. And dark matter is not our first rodeo. In the 19th century, for example, scientists measured the energy output of our sun and showed its effect on our seasons and climate long before anyone knew that the thermonuclear fusion is responsible for that energy. At the time, the best ideas included the retrospectively laughable suggestion that the sun was a burning lump of coal. So they did not know that the sun was doing thermonuclear fusion, and they thought that it's burning, something, and we get the heat and energy from that. But they did not know sort of the details of what was a burning and the fact that the sun is doing nuclear fusion, because we get heat and energy from in various ways. If you burn a candle, that's heat and energy that's coming out of that candle, but it is not a nuclear fusion reaction, right? So just by looking at the sun, it might not have been very obvious in the past exactly what it was doing. We knew something was burning, but a candle is burning, but a candle is not doing thermonuclear fusion. So we had to do further work to understand what happens in stars and things like that. And so that's what he means, that this book, that it's not our first rodeo when we have to come up against something that we don't understand, and it takes a lot of further research. Okay, that's kind of normal at this point. So at the time, the best ideas included the retrospectively laughable suggestion that the sun was a burning lump of coal. Also in the 19th century, we observed stars, obtained their spectra, and classified them long before the 20th century introduction of quantum physics. which gives us our understanding of how and why these spectra look the way they do. So, like sometimes we know certain things by observation, and then later on, there is the insights as to why it is the case. Quantum mechanics wasn't even discovered until the 20th century, and we were getting the spectra out of stars from before then, right? So unrelenting skeptics might compare the dark matter of today to the hypothetical now defunct ether proposed in the 19th century as the weightless, transparent medium permeating the vacuum of space through which light moved. So remember the days of when we did not have the special theory of relativity in the late 1800s even. People thought that there might be something called the ether, which lets electromagnetic waves wave. They did not have the proper understanding of exactly how light worked, and that the light was basically electric and magnetic fields oscillating and traveling and doing the waving. But they didn't understand. Like, they thought that you need to have some kind of medium for a wave to travel. And they came up with this ether concept, which is it seems very silly now, but that was where the understanding was back then. So we have to be patient. Sometimes we find something, we observe something, we measure something. It doesn't make any sense, but we have to keep going and keep researching that topic. Thank you. Thanks for being here. So they didn't know. They didn't know how light moved back then. So they proposed this ether thing, weightless, transparent medium permeating the vacuum of space through which light moved, until a famous 1887 experiment in Cleveland showed otherwise, performed by Albert Michelson and Edward Morley at Case Western Reserve University. Scientists asserted that the ether must exist, even though not a shred of evidence supported this presumption. As a wave, light was thought to require a medium through which to propagate its energy, much as sound requires air or some other substance to transmit its waves. But light turns out to be quite happy traveling through the vacuum of space, devoid of any medium to carry it. Unlike sound waves, which consist of air vibrations, light waves were found to be self-propagating packets of energy requiring no assistance at all. So the fact that light was such a different wave than sound waves was sort of a surprise. People didn't understand how light waves really worked in the 1800s. And by the way, that was when Maxwell's equations came out, Faraday did his work, people started to see the connections between electric and magnetic fields, right? So they did work on electric and magnetic fields a lot and came up with like all of electromagnetism, but still didn't fully maybe understand how light travels. So things can take a while. Just because you've done this one part doesn't mean that you understand all of the parts. So basically you're kind of like maybe finding pieces of the puzzle along the way. So something that was a puzzle back in the 1800s, later on, of course, we realize more. And he's kind of comparing dark matter to all of this because dark matter just seems like such an absurd, ridiculous thing at this point where we're like, do we even understand gravitation? What is this missing mass, etc.? But it might just be something that we have to keep probing and further researching because it's not something we fully understand. There's a bigger picture, a bigger insight that we're missing at this time, okay? So dark matter ignorance differs fundamentally from ether ignorance. The ether was a placeholder for our incomplete understanding, whereas the existence of dark matter derives not from mere presumption, but from the observed effects of its gravity on visible matter. So even though we don't understand or we don't know what dark matter really is, but Uh, hello. So even though we don't know what dark matter really is, at the same time, we're proposing something like dark matter, not because we want to or it's our hobby, but because we kind of have to. And it's because of the evidence we see of the effects of its gravity on visible matter. And so it's not just a presumption or an idea. It's sort of like something that we're compelled to have to address. Okay, so we're not inventing dark matter out of thin space. Instead, we deduce its existence from observational facts. Dark matter is just as real as the countless exoplanets discovered in orbit around stars other than the sun, discovered solely through their gravitational influence on their host stars and not from direct measurement of their light. So he's comparing it to something else that people consider quite real, which is the discovery of exoplanets, which exoplanets are quite difficult to discover because they're planets, they're not stars, and stars produce a lot of luminosity, so would be in that way a bit easier to discover. But planets, planets don't have their own light. They might have a bit of radiation like Jupiter does, but of course, compared to their home star, they have like almost no luminosity, right? So, and definitely not any visible light, probably. So it's difficult to discover planets, and we often have to resort to their effect gravitationally on their star, which is, by the way, a pretty small effect depending on the planet. So, of course, because stars are generally a lot bigger, right? But remember that we're all actually orbiting our combined center of mass. So, hello, Stephen. Thank you, Stephen, for the super chat. Goodness gracious. Thank you, Stephen. Appreciate you. So it's kind of like trying to discover, say, a Jupiter if you were not part of this solar system and looking from somewhere like Proxima Centauri, right? Say you're actually part of the Proxima Centauri system and you're looking here in our direction of where our solar system is, and you're trying to find, say, Earth or Jupiter from far, far away. And so you might resort to something like when there's a couple of ways. You can literally wait for when the planet will cross over the star from where you're looking and dim the luminosity of that star a little bit, which will be very small. Or you can look for little wobbles gravitationally, because actually both the star and the planet are orbiting their common center of mass, right? So, but it's not easy, right? So people sometimes find that the gravitational way might actually be a bit easier than the luminosity way, because, both are hard, but the luminosity way, the planet will have such a small effect on the luminosity of the star, right? So people are like, okay, let's look at gravitationally and find these exoplanets, and people have successfully discovered many, many exoplanets at this point, and there's a whole live on that, and we've talked about it before. But you know how we discovered these exoplanets based on their gravitational effect on their stars? Well, similar to that is what we are saying with the dark matter. It's not like dark matter, we found it in a different way. Exoplanets we were actually trying to find. Dark matter we were not trying to find, but we just stumbled upon as an inconvenience because we found those issues with our measurements in the clusters and the galaxies and whatnot, with those things moving too fast. But this too is a discovery by means of gravitational effects. So it is as real as the exoplanet discoveries is what he's trying to make the point of, okay? So it's not like something that's not real, just a bogus thing we dreamt up. Remember, we We really don't want this inconvenience. So if we didn't discover it and it didn't hold a lot of weight and didn't affect a lot of things, we really would not be pursuing it for almost 100 years, okay? So the worst that can happen is we discover that dark matter does not consist of matter at all, but of something else. Could we be seeing the effects of forces from another dimension? Are we feeling the ordinary gravity of ordinary matter crossing the membrane of a phantom universe adjacent to ours? So it can get pretty crazy and honestly quite fascinating. Either there's a bunch of missing mass that only interacts gravitationally, or it could even be something very fascinating, science fiction-y sounding. But I mean, facts are often more interesting than fiction, right? So it could be this situation of maybe there are other universes and maybe they're interacting with us somehow in other dimensions that we know not of or measure not of yet. Because, I mean, that would not be such a... The thought is real, right? The thought would not be so unfounded if we did think of other dimensions in this matter, in this topic, I should say. Because remember how superstring theory demands extra dimensions? And superstring theory's motivation was to unify these different parts of physics that are not generally unified, like gravitation and quantum mechanics. But the only problem is that superstring theory requires a lot of extra dimensions, either a total of 10 or 11 dimensions, including space and time. Mainly these extra spatial dimensions, right? Like 6 or 7 spatial extra dimensions. But those dimensions are very small, tiny, curled up, and difficult to measure, if not, in fact, not difficult, but impossible to measure at this point. So we cannot test it out. So the thing is, now given that we know this, if someone suggests that maybe dark matter, because we don't know what it is, if someone suggests that it is there, but it is some other dimensionally phenomena that we're feeling somehow gravitationally, that would not be so crazy, right? So let's keep on going. So could we be seeing the effects of forces from another dimension or other dimensions? Are we feeling, so do we feel it somehow gravitationally? Are we feeling the ordinary gravity of ordinary matter crossing the membrane of a phantom universe adjacent to ours? And this will also, of course, requires that there are other universes. So multiverse people, this is your moment. If so, this could be just one of an infinite assortment of universes that comprise the multiverse. Sounds exotic and unbelievable, but is it any more crazy than the first suggestions that Earth orbits the sun? So, depending on who you are, it may be crazy or not so crazy. We can talk about Einstein-Rosen bridge as well, also known as Alice in Wonderland. So, but is it any more crazy than the first suggestions that Earth orbits the sun? So like crazier things have happened. Science has always been a bit crazy, right? And then some things are proved out. So that the sun is one of 100 billion stars in the Milky Way. I mean, that's pretty crazy, right? But it's true. Or that the Milky Way is but one of 100 billion galaxies in the universe. Even if any of these fantastical accounts prove true, none of it would change the successful invocation of dark matter's gravity in the equations that we use to understand the formation and evolution of the universe. So it's kind of like our cosmology studies and theories and calculations that we do at this point have to invoke dark matter. We actually had a number of live sessions about cosmology and cosmic ingredients, and we have named them. These are photons, baryons, neutrinos, dark matter, and dark energy, right? So at this point, cosmology and the evolution and formation, well, I should say the formation and evolution of the universe also requires dark matter, and we put it in, we account for it. We have to account for it. It's not because we want to, but we have to. And even though we don't know what dark matter is, we do put it into our calculations for cosmology, okay? So, because we have to. So, it's almost like a lot of progress in cosmology has been made with this in mind, but a little bit of a concerning fact is that we still don't know quite what it is. And that's been taking a long time to unearth, if you will. But, you know, sometimes for a really hard problem, maybe 100 years is not so long, right? So other unrelenting skeptics might declare that seeing is believing, an approach to life that works well in many endeavors, including mechanical engineering, fishing, and perhaps dating. It's also good apparently for residents of Missouri, but it doesn't make for good science. Science is not just about seeing, it's about measuring, preferably with something that's not your own eyes, which are inextricably conjoined with the baggage of your brain. That baggage is more often than not a satchel of preconceived ideas, post-conceived ideas, and outright bias, says Neil deGrasse. So that is all to say that this topic, it's kind of like, until it's settled exactly what dark matter is, there will always be skepticism. But we have to keep in mind the things that we know and the things that we don't know, right? We have to understand, I mean, once you know a lot of things, that is when you start to understand what you don't know. And it is important to know what you don't know in all of this. Because as I said, we're doing a ton of cosmology with dark matter accounted for. We're doing astrophysics with dark matter accounted for. But of course, we have to now also discover what dark matter really is. So it's almost like we're still working on the puzzle. It's never done, okay? And that is something that we also have to be quite comfortable with in science. We never can be really fully done with anything. There's always something you don't know. But just definitely know a lot so you don't know what it is that you don't know. If you don't know what you don't know, then that could be really bad. Okay? Great. So, hello everybody. Thank you so much for being here. Can we get 200 likes? Oh boy. Excuse me. Thank you for liking and sharing and subscribing, guys. Really appreciate it. By the way, someone commented that if I'm coming to Italy, and I would like to say that I really want to come to Italy, but I hope that I can do that sometime soon. What did I call this live? See, I didn't even know that I would talk about exactly this, but I did want to finish the dark matter topic. Thank you guys for still being on. There's a little bit left, okay? So we will finish up that discussion. And then for next time, which is probably going to be tomorrow, we will start up with dark energy. Okay, so because Copenhagen, of course. I don't think I've been there yet, so that would be lovely. I've been to Italy, not all of it, of course, but I loved Italy. Of course, I love the UK, but I've never been to Copenhagen. Thank you all so very much. Are you astrologer? Well, I know a bit of astrology, but mostly the expertise is in physics, cosmology, astronomy, and astrophysics. Not in any particular order. Probably the astrophysics being mainly what I do. So the fresh air. Astrophysics is my favorite, guys. That is pretty much my favorite topic. Okay, great. I called this Merry Christmas Live, join now. And then I talked about dark matter. Okay, that's fine. That's fine. Hopefully people know that there's always some physics that is to be discussed in these lives. And I have a lot of lives. These lives have been happening now for over a year. So if you're ever having difficulty sleeping, you should go play some lives from the past. And we've probably discussed similar things there. And we've also discussed many other topics like quantum mechanics and all kinds of physics. I can tell you what we did not discuss. It's probably lasers. I don't do much laser physics stuff on here. Stream timings, probably again tomorrow evening. So like it's my evening time now in Boston. So I'm on the East Coast in Boston. And tomorrow I want to go to the gym and then probably do this again. Thank you for the gift. Thank you so much. Thank you so much, Tony, for the floating heart. Really appreciate you. So what we'll do is we will continue tomorrow after the gym. Probably like in the evening tomorrow. So generally I'm an evening person. And we will do that. So tomorrow's the 26th. Yeah, okay. So gym and then this will be tomorrow. Olive Garden. Okay, so let me finish up this dark matter topic. I have to go and update some of the previous live descriptions, details, thumbnails, and all that. But please do look at my older lives. If you're new, then we have a lot of these discussions done in the past. So don't feel shy. Just go digging under the live tab of the channel. And I think you'll find a lot. Okay. So we will now keep on going. And then I have dinner. So I'm not very good at time. Time is relative. I do like unlimited breadsticks. Oh my gosh. I like when something is unlimited, like the universe. Thank you guys for the gifts and support. What's for dinner? Guess. Guess the cuisine. I mean, it's Christmas, so guess the cuisine. Okay, so 80, 23. Okay, we will keep on going. Okay, so by the way, I'm gonna go hello Poland, hello darling. I'm going to go get dressed and ready so I can show you guys my outfit as well for dinner. Chinese! It's definitely gonna be something Asian because it's Christmas. So what else is open? And I'm not sure exactly what, but it will be from Chinatown, the food items. Chinatown has Taiwanese food, Chinese, Korean, all kinds of Asian food. And so once I'm done with the dark matter topic with you guys tonight, I'm gonna go take a very quick shower, get dressed, and show you guys my dress, and then do my dinner, start my dinner situation. Billionaire, hello. Having resisted attempts to detect it directly on Earth for 3/4 of a century. So this dark matter situation has been going on for almost a century, like I told you. Dark matter is still a mystery. Particle physicists are confident that dark matter consists of a ghostly class of undiscovered particles that interact with matter via gravity, but otherwise interact with matter or light only weakly or not at all. Because remember, there was a time when, years ago, when people even considered the neutrino to be a candidate for dark matter, because the neutrino, remember, also does not interact with light, but does interact with other things weakly or through the weak nuclear force. So you can see how, in terms of, you can see how in terms of particle physics, it's actually not that crazy. We have something like the neutrino already, which is pretty ghostly, right? But the neutrino is discovered and measured. So this robe is from India. It's very wrinkled, but it's comfy. I need a massage, yeah. Actually, I'm not sure why I did not get a massage as a gift on Christmas. I definitely need one. The world's largest particle accelerators are trying to manufacture dark matter particles amid the detritus of particle collisions. So, you know, at the collider stuff, they do try to discover dark matter, of course, and specially designed laboratories buried deep underground are trying to detect dark matter particles passively in case they wander in from space. An underground location naturally shields the facility from known cosmic particles that might trip the detectors as dark matter imposters. Although it all could be much ado about nothing, the idea of an elusive dark matter particle has good precedence. And then he talks about what I just talked about. So Neil deGrasse and I are not too different. Neutrinos, for instance, were predicted and eventually discovered, even though they interact extremely weakly with ordinary matter. I gave the same example. Neutrinos are also elusive, and they're not crazy because we've discovered them. So dark matter is not that crazy either. So sometimes I say, when people join and don't know me and have never seen my channel, I say that, well, you know, Neil deGrasse, he speaks about these topics. I'm like a little bit like that. Well, a lot like that, but cuter. So anyway, neutrinos, for instance, were predicted and eventually discovered, even though they interact extremely weakly. The copious flux of neutrinos from the sun, 2 neutrinos for every helium nucleus fused from hydrogen in the sun's thermonuclear core, exit the sun unfazed by the sun itself, travel through the vacuum of space at nearly the speed of light, then pass through Earth as though it does not exist. The tally, night and day, 100 billion neutrinos from the sun pass through each thumbnail patch of your body every second without a trace of interaction with your body's atoms. In spite of this elusivity, neutrinos are nonetheless stoppable under special circumstances. And if you can stop a particle at all, you've detected it. Dark matter particles may reveal themselves through similarly rare interactions, or more amazingly, they might manifest via forces other than the strong nuclear force, weak nuclear force, and electromagnetism. These three, plus gravity, complete the Fab Four forces of the universe, mediating all interactions between and among all known particles. So the choices are clear. Either dark matter particles must wait for us to discover and to control a new force or class of forces through which their particles interact, or else dark matter particles interact via normal forces but with a staggering weakness. So dark matter's effects are real. We just don't know what it is. Dark matter seems not to interact through the strong nuclear force, so it cannot make nuclei. It hasn't been found to interact through the weak nuclear force, something even elusive neutrinos do. It doesn't seem to interact with the electromagnetic force, so it doesn't make molecules and concentrate into dense balls of dark matter. Nor does it absorb or emit or reflect or scatter light. As we've known from the beginning, dark matter does indeed exert gravity, to which ordinary matter responds. But that's it. After all these years, we haven't discovered it doing anything else. For now, we must remain content to carry dark matter along as a strange, invisible friend, invoking it where and when the universe requires it of us. And that is the end of that chapter from this book by Neil deGrasse Tyson. Next, we will talk about dark energy tomorrow. The next chapter is about the fifth cosmic ingredient, which is dark energy. But we covered a pretty big one tonight and talked about a pretty big one tonight to finish up the topic of dark matter from before, because dark matter is the second most important ingredient of the cosmos after dark energy. She'll start arguing about neutrinos and all you asked was what you want for dinner. Hello. Dark energy is anti-gravity, correct? You mean that, right? Dark energy is the anti-gravity. Imagine getting into an argument and this is your wife. Good luck to that man. Aww. Well, thank you, Solomon. Thank you guys. Thank you so much. You guys are so sweet. Thank you. Intellect girl, do you believe in reincarnation? I might, but I also cannot depend on it. I think we just have the one life, so we must go to Brazil now. Hello, Solomon. Hello, North Korea. Hello, advances. Hello, Christmas. Take a chill pill. Can you do a gift? You might actually get something done. Aww. Chicken head particles. More dangerous. Far cuter. Aww. Thank you, guys. Thank you, thank you. This is Sandeep from Delhi. Hello. Ether, loved that. Neutrinos smell funny. Thank you, Manuel, for the flower. Okay, guys. So, somebody asked me to take a chill pill. Feliz Navidad. Okay, guys, thank you so much for joining. I will keep the chat open so that I'm not sure what my dinner will be, but it will be from Chinatown in Boston. It could be Taiwanese, it could be Korean, it could be Chinese, it could be Thai, I don't know. Hello, Germany. So, everybody, Merry Christmas to you so very much. Thank you so much for joining. Please stay on. I'm gonna quickly change and put my dress on for dinner and then show you guys, and then I'll sign off and go on with my day. So if you guys want to keep on chatting and whatnot, please feel free. Chat is open. I'll read any comments. Hello to Russia. And as always, your support and love means a lot. And happy birthday, Michelle. And thank you so very much for all the support, gifts, comments, chats, likes, shares, and subscribers. Thank you, thank you, thank you. Mwah. I'll be right back with my dress on, because as you see, I'm in my house coat. And I probably need to get a little bit cleaned up, okay? Add you to the live. Aren't you already added? Feliz Navidad. Feliz Navidad. Please do subscribe, yes. Subscribe so you can come back to the channel, see our shorts, clips, videos, lives, come back to the live. Really appreciate you. Thank you and welcome to Syria. See you soon. I'll be back with my dress on, okay? Share and subscribe. There. Hi, Fuji. Swatchy. How are you doing? Okay, everybody. Now I'll go upstairs and change. See you soon. Give me Baji. Gosh, oh gosh. My goodness gracious, guys. I am very late. Here's the earrings. Here's the coat. I have to get ready in the Uber. Here's my socks and whatnot. I will see you soon. Indeed, I will have to finish doing my hair in the Uber. Here, we'll do the earrings here. Thank you. Oh God. It's 700 feet away. 500 feet away. Ubers come very fast in Boston. Oh God, oh God, oh God, oh God, oh God, oh God. Thank you guys so very much. Before Uber charges me any further, I must go. Let me message. Send a message. Come on, be right there. Okay, guys. See you so very soon. See, I have my hairbrush in the bag, so that I can do this in the Uber. Actually, I'll keep the live on. You guys keep on going. Keep on going. I will maybe, oh, it might die, but you can keep on going and I'll say hi to you from the car. How about that? How about that? Okay? I'll say hi to you from the car. Thank you so much, guys. Here's the dress. And I will say hi to you from the car from the other phone. So, thank you. Good night, sleep tight. I gotta go. Yes, I'm running late. I'm running very late, and this is the mirror. This is the mirror that I have picked. Okay. Thank you. See you soon. See you very soon. Mwah. See you very soon. I have to, as you can see, my hair is a mess. That will be in the car. Mwah. Mwah. Okay, bye. Okay, bye. The driver says, okay, got it. Mwah. Thank you, driver. Good night. Good night and sleep tight. See you very soon. If the phone dies, that's okay. The live will end that way, but it still has some life to it. Okay? See you so very soon tomorrow. Mwah. Here's the dress. Okay. There. Okay. All right. Sachi, Mama. Mama has a dinner. Okay. Up and off. And where to go? Off, and off. Okay. Suji, Mama has to go.